Okay, so some have asked us, about the paste and about doing the pads. I figured I'd just show you one. So this is the card. These little GPU dies are about 20 millimeter by 20 millimeter even. So we'll just put that to 20, 20. You can see that, that's at 20. Right on the money, about 20 millimeters. So if anybody else is wondering about what the mounting holes are, should you be wanting to do your own pads, those are right center to center, about 54, about 54, and they're square, 54 square. So we do have these kind of heat sinks that when you make the card naked, I'm going to grab a naked card. So one of the problems is if you just run the regular heatsink that comes with it, one, it's a blower style heatsink, right? So it's not going to work very well. But if you mount this directly like this, and we have some running, the heatsink is like a 3 millimeter pad to cool the memory. And we have two of these running like this. The problem is this right here, like this, it runs fine. It'll do 65 mega hash in the immersion, and you can make a nice little stack with it, right? The problem is the GPU runs about 10C hotter, and the memory runs in the 80C. So in hot summertime, that might be a problem because that means you're going to be about 90s, mid 90s in the summertime with immersion cooling here in the deep south. And the GPUs are going to be somewhere in the 70s maybe, because right now they're about mid 60s on the GPU and about 80s on the memory. Raise that about 10C and you're easily 90s on the memory and 70s on the GPU, running it just like this. Now technically that would work. Problem is I think once you get a node stack, where you stack these one like that, one like this, one like that. We have one running now, and the problem is you're going to run into flow issues and all that kind of stuff. So what I thought about doing is modifying one of these, drill some holes, and then because this sits instead of on its little purchase that these have, these would sit flat. So now giving us about probably a 2 millimeter pad. I think you're going to run into the same issue. I also have one of these in copper because I wanted to play with the copper side, a copper heatsink. But so that narrows it like by 1 millimeter. I think it would be doable. I just don't know that it would be as good as with just the regular casing. I have some other ones here. I can get these apart. These just got a little taller stack, a little taller heatsink to it. So this one will be about the same. So I think what I would have to do to make this work is I don't know if you can see this on camera. That is still about a 2 millimeter, possibly 3, but I think it's about a 2 pad that you still have to use. And that could be a problem because the memory just doesn't get cooled as much. I also think that because of the design of the original heatsink, it sits on there, and maybe I can get that on camera. Its design leaves it well, you have to use a 3mm pad with this. And so there's two problems with this. Number one, this heatsink that it comes with, the A4000, is not designed to cool the memory. The memory is not cooled by this heatsink. And you can tell that because when you put it together in the card itself, right? This heatsink does not touch the aluminum case for the GPU. The memory is cooled by the aluminum case itself, and I think that's why a lot of people complain that oh, the card gets really hot. It's not really hot. It's just that the case is what is sinking the heat, and it's a good design and a bad design. It's a bad design. Well, it's a good design for immersion if you want to run just the whole card. It's a bad design if you want to try to make them naked. So the only way that I could actually get a heatsink, I would have to have these manufactured with a cutout in the center of this for the GPU. I'd have to mill out maybe 2 mil, and then you could sit that on there, and then and then you'd have like a 1 mil pad on the memory, which would be ideal. And I do have a friend with a CNC, and I'm gonna try to get a couple of these try to get about 2 mils cut out of them. I'll maybe try 1, try 2, try 3, and see what I can do with that. Because ideally, you could really make a very dense stack, with one this way, one that way, one this way, and then, and get that, and then get your density really tight. You could get 12 cards, in something, a foot long maybe, giving them an inch. But you would have to use a heatsink, obviously, quite a bit shorter than this. I don't think you need much. I think maybe, a centimeter, 10 mil, something like that. I think is all you would need to make it work, because it keeps the GPU cool with this little thing, and it's half centimeter. So, I mean, you wouldn't need much more than, say, this depth. You just need it to be an open heatsink rather than closed, so the flow gets through it a little better. So that's the problems with trying to run it naked. The power mosfets, they run just fine in the immersion without a heatsink on them. Obviously, you can't run it with no heatsink because the memory and the GPUs just get hot. Not enough surface area. And if you wanted to shunt mod these, there it is. And I will be trying some of that later too, because we do want to see if we can get these to go a little better than what they do naturally. It'd be interesting if we could get 160 watts out of them for immersion mining. Because immersion mining, these things run nice and cool. So back to the case. The case here, the memory, as you can see, this card sits right there like that. So the memory is being cooled by this aluminum shell, and then the heat radiates through it. The power MOSFETs get a little bit here. In immersion, I have found that you don't need a heatsink on the power MOSFETs. So it's just amazing how well. There is one problem, and there is a little kickback. When you have it in the immersion, this fan, these blades are way too tight. So when you have it in the immersion, you just get a bunch of fluid kickback, and I can show that later. It does move some through the card. It's very slow. However, it does seem to be enough. So that is the problem with trying to run these naked and save a bunch of space and not run the fan. I did have one viewer ask, that was commenting about, with fans on, with fans off. Right now we got 24 of these dumped, all with their fans on. Excuse me. And I have 2 in a test tank. And what we want to test is we're just going to disconnect the fan and see if this thing just sitting in the fluid is enough to keep this cool, because there is such little flow that happens because of this fan that I'm not sure it's warranted to even have the fan connected. In fact, it might be better just to take the fan out, and convection will move the heat up. As the heat sink sitting in there gets hot, it's going to naturally want to go up and take the heat out. The cards are in the tank like this. This is the best way that we have found. And let's see if I can show you how we mount that. Give me just a second. So, the way that we're mounting these is this little 1.5 inch bar, and we drill our holes, and then we drill 2 main holes, support holes. And you could probably do this with several different bars, probably even a flat bar, but I like the angle because it's very rigid. Even with 12 cards on here, this bar supports it very well. So Nvidia did do something really cool for their server setups. They put in 2 M3 drilled and tapped holes here that go straight into the case, and they're in a void that interferes with nothing. So it's very nice that they did that, because now I can take this thing, mounting bar, and I just simply make holes big enough, and then it mounts in there like that. So they just mount across the board, and then they hang in the tank. They hang in the tank kind of like, you can't really see it, but they hang in the tank like this, but vertical, obviously. So it's a very interesting setup that we're doing for immersion on these. And so the idea is let's test a card, and I think I'm just going to remove the fan to promote as much flow through it as well. I have one card that I've modified the cover plate, where I just cut out every other one to help promote some flow, because the immersion fluid is a little bit thicker than water, and it doesn't like to flow through tight little holes. So I do have one card that is in the tank like so, and sits in there like that. The problem is, temperature-wise, I've noticed nothing on that one card. In fact, if you just look at temperatures, you can't tell one from the other. So I don't think the holes helped much. It also has, because it's a blower card, it does have some ventilation there. So we've thought about even just taking this plate off, because we don't need them. The idea is that we want to make it as little work as possible to put these into immersion. So ideally, we could run them without fans, and I will be taking a fan out of one that we've already got immersed right now, which is simple, 3 little screws. Run this little cable out that runs through here, and then through here, and then you just unplug it there. So I'm going to try that. Subscribe, because that'll probably be a video on its own doing that testing on and off. And so on this one, I just wanted to show you a little bit of, we'll do a little montage here, that you cannot run these immersed. The pads are fine. What you can't do is run the paste. Paste and immersion, it just washes out. So it's a little bit of a pain in the butt, because you got to take it apart. However, these come apart really easily. There's 8 screws that hold this thin little cover on, and then once you have that off, you pop the 4 screws for the GPU and for the die cooler. Pop that out, clean it up, and for cleaning, we use MG Chemicals. It's 99.9% pure, aka rocket fuel. And I got a bunch of that, and we have a bunch of Q-tips that we clean off. Now, as far as pads go, there is an expensive route and a cheap route. You can use Innovation Cooling's graphite pads. These work really well, by the way. Uh, they're a little pricey for what you're getting. Uh, you only get 2 pads out of this, and it's not very good for what we're wanting to do. So what we get is these pads that just get shipped off of eBay like this. I can't remember if I got this off eBay or Amazon, but I'll put a link in the description. How about that? And these are iridium pads. And you want to be real careful not to bend them. I'm not going to open this just yet because I don't need to, but I'll probably open it later. But I'll put a link in the description for these as well. I've used these a couple times already, and excuse me, and they come out good. What this is a I think this is a 0.1 mil. It almost looks like bubblegum wrapper, but a foil. But it's iridium foil, and this thickness has worked really well. And you do have to do a little more work. Like I said, you're going to have 20 mil. So you have to cut these out into 20 mil squares, which is not that hard to do. Let's see here. So basically just set this thing up for 20 mil, and then you can just go. And so I've gotten to the point where I just use this to make my marks, because all you need is just like a slight little mark on it, and you know, just kind of hold it like this. It's kind of hard for you to see. How can we do that where you can see it actually? Backwards. So essentially, I just hold it to the edge. This doesn't have to be super precise. You can't have this iridium, because it is conductive, touch any of the little resistors or capacitors around the card. So you don't want it touching anything other than the GPU die. And I found that to be fairly easy, just by simply making a little mark here. I could use like a regular measuring tool or whatnot, but this works for me until I find something better. But essentially just drag this across like so. Then you got your 20 millimeter square. I really would like to find, if any of you have got an idea on how to do this easier, but so that just gives me a little bitty line. And this foil, it's like metal. It's very easy to cut. So I just take a regular old box cutter, and you have to hold it on both sides or else it'll tear. It's so thin and fragile that it will just tear on you. Sometimes they don't cut all the way through, and you can just bend it like a piece of metal, and it'll stress cut. So one of the problems that if you just put it on there like that, obviously if you try to move it around or put a cooler on it, flip it over to put the screws on, it just falls out, right? So the workaround. So the workaround is just use a little bit of thermal paste, and we just get a hair of thermal paste on the tip. Not even that much. Not even that much. It just needs to be a slight bit of paste on there. A hair, and then just dot it like that on the cooler. I don't know if this washes out. We haven't torn down any yet, but I figured it's probably going to wash out. You got to also work the corners so they're not like bent down. And then once you got it pretty much flattened out, just stick it on there where you want it. and you don't have to worry about, like, you know, is it perfectly flat or whatnot. You don't want any bends in it, because what I found is once the cooler on there, these flatten out now, it does not fall off. So that slight bit of paste just keeps the cooler from falling off. And on these, there's a slight notch here. And how to tell which way this goes. One, if it's your first time taking apart a A4000, you can just take pictures so you know how it goes back. But there's a little notch here, and then these have a slight part to them that's not covered, and that goes to the front of the card. And the little notch just goes where that screw is. So it's real easy to put back together. Literally just drop it back into the hole and flip it over. It drops, and there's not a whole lot you can do about that. My daughter, Andy, has taken apart 12 for us to do, and I'll do one, and then we'll just montage the rest of them. Oh, and I got some paste, and that goes everywhere. So we just go back with the retentioner, get that started. And imagine that thing moving around. If it does move on you, you will notice the temperatures are not as good as they should be. So if you put together, a whole rig, of 6, 8, or 12 or something like that, the temps should be all within, say, 5 or 6 C of each other. Switch out the bit and put the cover back. So I thought about a ton of different ways to do these solid cards like this. There you go. And ready to be dumped. It put the power, put the riser on, all your cables come out the back. And you're good. I thought about a bunch of different ways that we can mount these, but what we wanted to do was suspend them in the immersion fluid. And right now our tanks are not optimized, obviously, but eventually there'll be 12 of them, and each node will just be a GPU wide, basically. If you guys got any ideas or want to CAD up ideas, you can get the dimensions online, but it's got those 2 mounting holes for when it's in a server rack for support. These things can go pretty close to each other. In fact, I think they can even touch, but we like to keep a little bit of room just for heat convection and all that kind of stuff. That's it for one GPU, and I think we'll just do a montage of the rest.
I look at people and I wonder all day, who are you and you are not the one in your way. And then I think about myself and I state, I'm a pretty boss with almost your brain waste. I'm a freak in the sheets, but I got class. I'ma grab an ass if you want it. Best you ever had, give it to you bad. Ooh. quiet with a big mouth. Listen for the doubt, then call it. Make you out for what you say to me. Look at every single date. If you got what I need, then oh, I'll take you on like a big deal. Legs you can unseal, key in ignition. Just keep me full like at a meal. Once in a while, feel alright. I know you like it, can't fight it. I might let you ride the wave. I'm New York and you're LA. Come together, feel the shock waves.
Hey guys, thank you for watching. We got a lot of fun content coming up. We have the immersion build coming up. We have the videos on the nodes that we built today coming up that we'll be dunking them. I thought that might be a fun thing to do. Hey, like, subscribe, hit the bell if you want to be notified. We thank you. We'll see you next time.